When we are talking on the statistical data, we need a statistical method to accept or reject our assumption. So today we're going to talk about hypothesis testing. Hello and welcome to another video of Business Analytics Complete course. As I mentioned, today we will talk about hypothesis testing, and we need to have a short review on previous lessons, a standard deviation and normal distribution, and then come back to this video. So if you need, please review previous lessons. Okay, let's continue. Hypothesis testing. Hypothesis is a statement of assumption about relation. You either approve the hypothesis or reject. It's made on basis of limited some evidence or experience. So you need to collect some evidence to prove or disprove the hypothesis. As example, there is a person who has been accused of murdering some person. So how does the judiciary work? The judiciary says that the person who has been accused of killing another person, so the accused person is innocent until proven guilty. So the assumption here is that he is innocent. So the prosecuting lawyers have to provide evidence to say that he is guilty. Null or alternate. The null hypothesis is an assumption. In a statistical test, the hypothesis that there is no significant difference between specified populations, any observed difference being due to sampling or experimental error. If you accept the null hypothesis, which implies that in a way you are saying that the alternative hypothesis is rejected or is false, all you would claim is. So when you reject the null hypothesis, you are saying that argument is accepted or your claim is true. So that's how you have to interpret the null and alternative hypothesis. Now let's take an example. A new drug is designed to cure symptoms of malaria more effectively than the existing drug. The new drug SBM and the existing drug DEET, right? Now let's see how do we design the null and alternative hypothesis in this case. So here we have a new drug, so the hypothesis should be null. I mean the new drug should be same as the old one. So what would be alternative hypothesis? The alternative hypothesis is that the new drug is worse or better. So whether it's worse or better than the old drug, and it's not equal to B, okay? The null hypothesis here is both drugs are the same. The alternative hypothesis has two parts. One, the new drug is worse than the older, and another one says the new drug, and another one says the new one is better. So you are looking at both. Here, if you frame your null hypothesis like this, yes, second row, the new drug is similar or worse than the old drug. It's like less than or equal, right? Here we have an alternative hypothesis. It would be a new drug better than the old one. And third row, we have a different position. The third one is the null hypothesis that the new drug is similar to or better than the old drug. Here we have three cases and three positions. Which one is the best case? What do you think? The best is first one because it's new drug and you want to see both the negative impact of the drug as well as the positive impact of their drug in other positions. As an example here, the third one, your assumption is that the new drug is similar or better than all that. So we can't assume that the new drug is better than the old um, one without even testing it and even proving it conclusively. So the third one that is not relevant to the first case is the most relevant second case, right? Um, which is the safe side, you know. So the first or second way, for example, you run a marketing campaign saying that if you spend at a particular store, you get a 10% discount. Now everybody goes and buys in the store and overall sales increase. So to assess whether the campaign had a significant impact on sales, which position do you select? Because it's a campaign, so it can really have a positive impact. You know, a campaign can't have a negative impact. So in this case, you want to see whether the sales are better than the old sales, and you can do the one thing where you are interested only on the positive side of it, and you are 100% sure that the campaign will only generate positive behavior from the customer and not negatively and not negativity. Now I need to remind you of an old topic. If you remember in the distribution lesson, we talked about skew in graphs as well as what is standard deviation and how to calculate it, right? Now, and to complete the hypothesis title, we want to talk about the level of uh, significance, and let's see how our lesson can help us today. So we have three cases. If you remember, standard deviation gives us a range. Range means the average amount and result that we are looking for. Here we find the standard deviation exactly the same previous lessons. According to the hypothesis method that you choose, and of course, uh, between these three modes, you should specify alpha space. Standard deviation does it for you. Alpha space shows alternative hypothesis space. I think this is simple way to understand it. So if your new data is located in alpha space, you should reject the null hypothesis. In drug example, the null hypothesis says new drugs are similar to or worse than old drug. In the chart, we find alpha space, and if we are faced with a new result in alpha space, reject the hypothesis and accept an alternative. It means new drugs are better. There are so many tests, and so it all boils down to creation of a standard deviation. Therefore, a standard deviation is important and you need to learn it. If the distribution is not normal, then it's not advisable to use this test. So first of all, you make sure the population is normal. If the sample size is greater than the population is not normal, and sample size is greater. In the previous lesson, We talked about normal distribution and standard deviation. In future days, we will have a review of what we learned so far, and you need to prepare a checklist for analyzing process, you know. But hypothesis steps. Number one, formulate a null and alternative hypothesis. Specify desired significance level, I mean alpha space. You know how to do it. Just calculate the standard deviation. Number three, determine rejection region. If you remember, we had three methods for this job. Number four, option sample evidence and compute the test statistics. This level is nothing but a standard score. And number five, accept or reject the null hypothesis. Okay, now let's have an example for a hypothesis and solve it with what we learned. In this example, we believe that number of TV sets in the United States per household is at least 3. So this is our assumption. At least 3. It means equal to 3 or more than 3, right? This is an assumption. The first step, make a frame for hypothesis testing and what is the null hypothesis. Let's formulate null and alternative. The null hypothesis says there are 3 or more. So the alternative should be less than 3 TV, yes? Step 2, specify the desired level of significance. For this job, it would be better if we could calculate the standard deviation, but in this case, we should be 90% confident. This is our acceptable percent. So the error can only be 5% or less. We need to calculate this percent for alpha space. Step 3. Where is the rejection region? If this is a normal distribution, here we have a mean. And how far is from the actual alpha being point? I mean, mean, average, okay? How far is from the actual alpha point? This is an acceptable space. Attention, mean point means at least 3, and we can reject the assumption or null hypothesis if data falling here and in the alpha zone. So let's compute. The next step is to option the sample evidence and compute the statistics. You can't go to each household and ask how many people they own. So suppose a big sample, a sample of 100 United States households is taken and the following results are optioned. So n equal 100, mean 2.84, standard deviation 0.8. Yes, we surveyed hundreds of households and the average number of TV sets is 2.84 and the standard deviation is 0.8. Now compute the statistics. Your assumption was United States households hold greater than or equal to 3, but the data which are collected showed it's only 2.8 and it's lower than 3, but is it significantly lower than 3? That's what you have to check. If you see here we have a 2.84, so how far an observation is from your expected value. The expected value here was 3. that you accepted that the average household in US will hold at least 3. So the expected value was greater than or equal to 3, right? But in reality it was only 2.84 minus 3 divided by the standard deviation, which is zero point 0.8, and a square root of 100. You remember in previous lesson we were doing observation minus the mean divided by the standard deviation. Now, where does this fall in the normal distribution? That is your step 5. So step 5, decide to accept or reject hypothesis. You remember we were saying that for 95% confidence the z or the critical value was a negative 1.645. So something is falling here. You reject the null hypothesis, and as you compute the statistics, here is negative 2, which implies that it's falling somewhere here. So it's significantly different from your accepted value. You had expected value was 3, right? But in reality, the data was negative 2.8. The data was only 2.84. As we saw in the previous sample collector, you expected 3, but it's only 2.84. So if it falls in this region, you reject the null hypothesis and say that since that is less than 1.645, less than 1.645, the statistics that the computer will reject the null hypothesis. And so when you reject the null hypothesis, what was the null hypothesis? The null hypothesis was number of TV sets United States households is at least 3. So hypothesis is rejected, right? So by rejecting the null hypothesis, you have accepted the already hypothesis saying that the number of TV sets in United States household is less than 3 because not greater than or equal to 3. Okay, so that's how you have to do hypothesis testing. So with that, we have completed the hypothesis testing example. So the key concepts are the same as of your computer, the standard score, the critical. The important thing is when computing the when doing the hypothesis testing is to frame your alternative hypothesis. So once you have null and alternative hypotheses, you should decide what is the significance level, whether it's 5% error, it's 5% error, you accept the 1% that you accept. Okay, so you have to decide the significance and then you have to collect some evidence and then see whether the collected evidence, how far is it from your expected value. If it's closer to the expected value, you accept the null hypothesis. If it's very far from the accepted value, in this case it was very far from the accepted value, you reject the null hypothesis. So with that of who completed the hypothesis testing. Okay, we can talk more about hypothesis testing, but it's enough for us for today. Now you know how to accept or reject assumptions. Okay, next lesson is about regression. It will be important lesson. Have a review on previous titles and get ready. I come back very soon.